Thank you, Bill. I'm pleased to offer some thoughts on the fourth strand of IChemE's roadmap, which is the contribution of chemical engineering to improve quality of life in the sphere of health and well-being. Now, we've bracketed health and well-being together, and I wanted to explain why. Good health is about more than the absence of illness, injury, or pain, and the World Health Organization defines good health as follows. It's a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. Now, chemical engineering has done much to contribute to physical, mental, and social well-being in the area of healthcare, certainly, and also in the wider realm of personal care products and consumer goods. So, I guess what I'm really talking about here is stuff. The stuff that makes our lives more comfortable, more productive, more enjoyable. The things that perhaps we here in the advanced economy take for granted, but things that a burgeoning middle class in economies like Brazil, Russia, India and China are now starting to demand in ever-increasing quantities. So what I've done in my 5 minutes is picked some examples from the last century to illustrate the key role of chemical engineering in delivering a better quality of life, and I'd like to start in the 1920s with one of the world's first mass-produced products. Polyvinyl chloride, or PVC, first attracted commercial interest in the early 20th century, but its rigid and often quite brittle properties thwarted attempts at exploitation. And now in 1926, a young chemical engineer named Waldo Seaman, working at the rubber company B.F. Goodrich, was trying to develop a glue that would bond metal and rubber. Now, Seaman experimented with various solvents and additives before he created a flexible and resilient variant of PVC that resisted attack by acids, alkalis, and certain solvents. Now, he managed to convince his management that there was a commercial potential in this new product, and that product endures to this day, and it's the construction material of choice for most water pipes and a whole range of other products, including credit cards, insulating tape, and the ubiquitous UPVC window frames and doors. It's a controversial material, I know, in some quarters, but it remains the world's third most widely produced plastic product. It impacts upon all of our lives, and it contributes to the well-being of millions. My second example is the antibiotic penicillin, which was first isolated, I'm sure many of you know, by Fleming in 1928. But it was World War II and the D-Day landings in 1944 which first saw this drug deployed on a massive scale. And you know, let me assure you that mass production of penicillin was a real headache, and the pharma company Pfizer was struggling to produce sufficient supplies of penicillin in anticipation of the casualties that were likely to result from the D-Day landings on the beaches of Normandy. And I quote one plant manager who said, the mold is as temperamental as an opera singer. The yields are low, the isolation is difficult, the extraction is murder, the purification invites disaster, and assay is unsatisfactory. Is it really worth it? Whilst many different disciplines worked on the scaling up of the production of penicillin, it was undoubtedly a Pfizer chemical engineer, a guy called John McKean, and a chemist colleague, Jasper Kane, who made the biggest contribution, because Kane and McKean cracked the production problem via what is known as deep tank fermentation. And I would contend, ladies and gentlemen, that it was worth it. Thousands of lives were saved, and as production increased, the price dropped from almost priceless in 1939, 1940, just 50 cents a dose by 1946. And variants of penicillin are still in use to this day. They're chemically engineered products, and they contribute to the health and well-being of millions of people worldwide. The post-war boom brought about a radical transformation in lifestyles, not least for women. And one single chemically engineered product, more so perhaps than any other in that era, changed women's lives forever. Many women take it for granted that they can choose if and when to have children. They are indebted to three people: George Rosencrantz, Louis Miramontes, and Carl Gerasi. And in 1951, these three people, two chemical engineers and one chemist, employed at the Syntex company in Mexico, produced the first synthetic progesterone, which would go on to be used in what we know as the contraceptive pill. Now, you could argue that maybe chemical engineers are in some way responsible for the permissive society. But the liberating impact of this breakthrough makes a significant contribution to population control worldwide, and it improves the health and well-being for millions of women, and I would argue men. My next example comes from the great outdoors. All over the world, walkers, golfers, fishermen, campers and others, they do their thing in all weathers thanks to the product which we know today as Gore-Tex. Gore-Tex was developed by a family of chemical engineering innovators, a father and son, Bill and Bob Gore. And Bill Gore had worked for DuPont's fluorochemicals business, specifically on PTFE, or what we probably know better as Teflon. And he was convinced that Teflon had applications beyond simple non-stick pans. And they tried many, many different applications of PTFE, but stretching the PTFE proved particularly tricky until one day Bob gave a sample what I would just describe as a good hard yank, maybe out of the frustration of being a chemical engineer, who knows. But to Bob's surprise, the material sample stretched by a factor of 1,000. And quite by accident, he'd created microporous PTFE. It's a fantastic insulator, and its fine pores create a waterproof and windproof but breathable fabric. So Gore-Tex was patented in 1976, and since then there's been no such thing as the wrong weather, just the wrong clothing. My final example, I've selected something which might be equally viewed as a blessing and a curse, and I'm sure there will be dozens of these things of various sizes in the room here tonight. Handheld electronic devices, from mobile phones, iPads through to laptops, have transformed the way in which we live. But the revolution led by Steve Jobs and others, of course, would not have been possible without high-power rechargeable batteries. Now, like most chemical engineers, Yoshio Nishi is not a household name, but maybe he should be, for he led the team that turned the lithium-ion battery from a research concept into a practical, commercial and viable reality. And he spent his entire career at Sony. He realized that lithium-ion batteries promised to overcome the environmental problems that were associated with nickel-cadmium batteries, and they also offered a much greater energy density. But in the early stages of development, people thought the lithium was too dangerous, the technology was too risky, and the whole concept was premature. Nishi prevailed, his team overcame these problems, and from 1985 or thereabouts onwards, the compact, lightweight lithium battery sparked a revolution in our briefcases and now tonight in our pockets, and improved the quality of our lives by making us permanently connected to the boss. I will conclude. PVC, the mass production of antibiotics, the contraceptive pill, Gore-Tex, and lithium-ion batteries, 5 examples that I've selected, 5 examples of chemical engineering innovation from the last century that I would contend have dramatically improved health and well-being, have changed the lives of millions of people, changed lives for the better, changed lives forever, I would argue, and that's what chemical engineering is all about. Thank you.